Okay, we have learned that if we can factor expressions, we can solve equations using the zero product property rule. So we want to be able to factor. So if I had asked you to factor this, you would say that's easy. Grandma's 3. I'm going to pull out x squared. I get 3x minus 4. Check at 3x squared plus 9x minus 4. And I have factored this. Okay, but if I asked you to factor the next one, you might think, oh, I'll take out a y. But then you realize, ooh, can't do a y because this term doesn't have a y. Then you're thinking maybe, oh, well, I could do 7 and 14, but that doesn't help you with all 4. So sometimes if you're factoring and there's 4 terms and they don't have a common factor, we're going to learn a new method, and it is called factoring by grouping. So if you turn to page 50 in your new packet, this is a new packet. It's chapter 9, part 2, 9.5 to 9.8, and page 50. Now, if we look at example 1 on page 50, it has 3x times x plus 2 minus 2 times x plus 2. Now looking here, if I wanted to factor, I would say, well look, this has an x plus 2 and this term has an x plus 2. So grandma must be x plus 2. And if I take out my x plus 2 here, I'm left with 3x, and if I take out my x plus 2 here, I'm left with minus 2. So this becomes x plus 2 times 3x minus 2. Now, to prove that that works, I'm going to rewrite it as 3x minus 2 times x plus 2, and that equals 3x times x plus 2. And negative 2 times x plus 2. So if I distribute the 3x to the x plus 2 and the negative 2 to the x plus 2, I get my original equation. Okay, so let's look at the next example on page 50. It asks me to factor y squared times y minus 4 plus, actually, no. We're not going to do that. We are going to look to the left on page 50 where we see example 1, 2, and 3. Let's go over example 1. 3n squared times n minus 1 plus 1 times n minus 1. Well, what does this term and this term have in common? N minus 1. So n minus 1 is grandma. When I divide this side by n minus 1, I'm left with 3n squared. When I divide this side by n minus 1, I'm left with 1. And we see 3n squared times n minus 1 plus 1 times 3n minus 1. So I have factored that. Now, try to do number 2, m squared times m minus 6 plus 2 times m minus 6. Try to do that on your own. Stop the video and start it again when you're done. So, we take out m minus 6 is grandma. So I divide this by m minus 6. I divide this by m minus 6. And I'm left with m squared plus 2. Okay? Now, let's try number 3. Now, if we look at number 3, we notice, there's an n minus 1 and there's a 1 minus m. So I'm going to tell you, let's hold off on number 3, and let's go back to example 1b. So y squared times y minus 4 plus 3 times 4 minus y. And notice I have the same problem. It seems like I have the same number and same variables, but opposite signs. So what that means is you can take a negative 1 out of this, and you will get the same thing inside the parentheses. So if I divide this by negative 1 and this by negative 1, that means I'm bringing out a negative 1. So I have to make this a negative 3. This becomes negative 3 times negative 4 plus y. which is the same as negative 3y minus 4. So if it looks like you have same numbers, opposite signs inside the parentheses, you can bring that negative out and you can have the same thing inside the parentheses. So let's go over that again. Y squared times y minus 4 plus 3 times 4 minus y. I want to change this to positive y, negative 4, so I bring the negative out here. And notice if I do that, I get negative 3y plus 12. And the other way, if I had distributed, I would have gotten 12 minus 3y, the same thing. Okay, so let's finish this. I'll go over it again. Y squared times y minus 4 plus 3 times 4 minus y. I'm changing this to y squared times y minus 4 minus 3 times y minus 4. So I take out my y minus 4, divide by y minus 4, and I'm left with y squared minus 3. Because if I divide this by y minus 4, I get minus 3. Okay, so now let's go back to number 3. And you're going to try to do that on your own. Stop the video, and I will do it right now. So 3n squared times n minus 1 minus 1 times 1 minus n. Now, I notice I have same numbers, opposite signs. I want to take out a negative, so I'm going to make this positive, this negative, this positive. So in essence, this is n minus 1. So now, grandma's n minus 1. And I'm left with 3n squared plus 1. Okay, so now we're going to see how this is going to help us factoring by grouping. So everyone look at example 2. Example 2 has y cubed plus 7y squared plus 2y plus 14. Now if you're told to factor this, you'll notice these three terms have a y, but this doesn't. So I don't have a greatest common factor for this. So what I'm going to do is factor by grouping. I'm going to group these two and these two. I notice the first two terms have y squared in common. When I factor out y squared, I get y plus 7. I notice this has a 2 in common. When I take it out, I get y plus 7. Now look what I have. I have y squared times y plus 7 plus 2 times y plus 7. I notice y plus 7 is my common factor, and I'm left with y squared plus 2. So now let's look at b. So for b, I have y squared plus 2y plus yx plus 2x. Again, there is no GCF. It's 4 terms, so I'm going to try factoring by grouping. Out of this first grouping, I see y. I get y plus 2. Out of the second grouping, I see x, and I'm left with y plus 2. So when I divide this by x, I get y. Divide this by x, I get 2. Now I notice grandma's y plus 2. So I say y plus 2, and I'm left with y plus x. Okay, so now let's turn the page and let's try page 51. Now sometimes, although I have to say very rarely, you might have to change the order before you factor. But when you look at this, do you notice it's not in descending order? If you put these terms in descending order, it's going to be much easier to factor. So that's what I'm going to do. X cubed minus 4x squared plus 3x minus 12. And once it's in descending order, it will work. I can factor this. I get x minus 4 plus 3, x minus 4, and I'm left with x minus 4 times x squared plus 3. So a rule of thumb is put them in descending order when you want to factor by grouping. So now I want everybody on page 51 to try checkpoint 1, 2, 3, and 4. Turn the video off and turn it back on when you're done and check your answers. Okay, So number 1, 5z, z minus 6, plus 4 times z minus 6. Obviously, z minus 6 is my GCF, and I'm left with 5z plus 4. For number 2, 2y squared times y minus 1, plus 7 times 1 minus y. Now I notice same numbers but opposite signs. So I'm going to take the negative out. I'm going to make this a negative 7. That makes this a negative 1 and this a positive y. So I can rewrite that as y minus 1. So then my GCF is y minus 1. I'm left with 2y squared minus 7. Okay, and for number 3, it's 4 terms. So I'm going to factor by grouping. X cubed minus 4x squared plus 5x minus 20. It's in descending order, so I group the first 2, take out x squared. Group the last 2, I take out a 5. Now my GCF is x minus 4, and I'm left with x squared plus 5. Now for the last one, number 4, I have n cubed. Now I'm just going to rewrite this because I notice this is not in descending order, so it's not going to work. But once I put it in descending order, it's going to be easy. So I take out n squared, I get n plus 8. Plus 6, I get n plus 8. So it's n plus 8 times n squared plus 6. Okay? So now, on the bottom part of this page, you will see guidelines for factoring polynomials completely. Okay, we're going to come back to this after we finish the other sections. So right now I want everyone to turn to page 55, and you are going to work on page 55 and 56 and complete it all. You will notice there is another video for page 55 and 56 if you get confused, and also you can go on to Google Classroom and look at the answer key to make sure you have these correct. So you are to complete page 55 and 56.